Welcome to my YouTube channel Cat, and today we will see what is the concept of electric field in case of capacitor. Okay, when the capacitor has no dielectric and when the capacitor has a dielectric, so what is the concept of electric field? Okay, so suppose that there is a capacitor, so we will see what is the concept of electric field. In case of capacitor, okay, normal capacitor and capacitor with a dielectric. So suppose that there is a capacitor which is having these two plates, okay. So suppose that the battery is connected like this, so here it will be having positive charge because it is connected to positive terminal and this is the negative, okay. Okay, so this electric field is told by, in this case, by the concept of Gauss law, okay, Gauss law. So what is phi? Phi is equals to charge upon epsilon naught, okay, and what is phi is equals to integral of E dot dA. Okay, if we will consider that E is constant, so phi is equals to E into A. Okay, so how we will tell this electric field in this case? Suppose that there are two plates, one is having this positive charge and one is having this negative charge, and we want to find this electric field. So how we will find this electric field? By the concept of Gauss law, and we will know from the Gauss law that charge enclosed by a closed surface is equals to Q upon epsilon naught. Phi, or the flux coming out of this surface, phi will be equal to Q upon epsilon naught. Okay, so this is the flux or the electric flux. Electric flux. So the electric flux coming out from the first plate will be equal to Q upon epsilon naught. Okay, so that's why this becomes equal to phi is equal to Q upon epsilon naught. So from this we will see that the phi becomes Q upon epsilon naught, but the phi is also integral of E dot dA. Okay, how is this integral E dot dA? E is the electric field in this closed surface and dA is the outer surface area of this surface. So outer surface area of this surface, if we will integrate in this whole surface, so what we will get? E into A, because we are considering that the electric field from this plate of the capacitor is constant. Okay, so that's why we will get what the formula of E will be equal to E dot dA is equals to Q upon epsilon naught. Okay, because if we integrate dA, it will be A only, because we are integrating in the surface of the capacitor plate. Okay, and the E we are considering it as constant. Okay, so if the E is not constant, so what we will do? We will put the function of E and we can easily get what is the flux. So this is the flux. Phi is equal to E into A and phi is equal to Q upon epsilon naught. Okay, so for phi is equal to Q upon epsilon naught and phi is equal to E into A, so we will equate it. E into A is equal to Q upon epsilon naught. Okay, so what we will get? E as E is equal to Q upon A epsilon naught. Okay, so this is the formula of the capacitor. Q E is equal to and the electric field will always go from positive plate to the negative plate. Okay, so E is equal to Q upon A epsilon naught. Okay, so this is the formula in the case of the capacitor which is having a no dielectric. Okay, so this becomes E is equal to Q upon epsilon naught in the case which is having a no dielectric. And what is the direction of the electric field? E will be equal to from the positive surface to the negative surface. Okay, so this is the formula of the electric field. Okay, in the case which is having a no dielectric. And what is here the potential? Potential is E into E dot dl. So we suppose that the capacitor is having a length L. So what is the potential between these two? E into L upon A epsilon naught. No. Q into L upon A epsilon naught. Okay, is equals to V. So Q into L upon A epsilon naught is equals to V. It will be equal to this potential V. Okay. This L is the length of the plate and A is the area of the plate. A is the length between two plates of the capacitor. Okay. So like this we will see what is the voltage in the case of the capacitor and what is the electric field in the case of the capacitor. Okay. So these are the two things which we have to remember, that how we will get this electric field formula from the Gauss law. Okay. And the and how we will get this potential, with the potential is equals to integral of E dot dl. Okay. So like from this we will see what is the potential QL upon epsilon naught, which is will be equal to the potential of the battery which is connected to these capacitor plates. Okay. And suppose that if we will insert this dielectric, which is having a dielectric constant of K. Okay, so suppose that this is the positive plate and this is the negative plate. Okay, so if we will insert this dielectric constant of K in this, so what is the electric field in this? So if we will insert the positive here, so what it will induce, a negative sheet of charge here will be induced in the dielectric. Okay, and if the negative is here, the positive will be induced here. So in this the electric field was from positive to negative like this, but here the electric field will be in the opposite direction in the case of the dielectric. Okay, so the electric field will be in the opposite direction. Okay, so we will see that since the electric field is in the opposite direction, so suppose that this electric field is E1 and this electric field is E2, so net electric field which will be inside this dielectric will be E1 minus of E2. So this is the E1 minus E2 is the net electric field which is there in between the capacitor plates. Okay, which is having a dielectric of K. So this, what will be this E2? E1 is Q upon A epsilon naught. This will change by a factor of K. K Q upon A epsilon naught. Okay. So this will be K Q upon A epsilon naught. So this will be the K Q upon A epsilon naught. This will be minus, this will be plus. E2 minus E1 will be net electric field. So net will be E2 minus of E1 K Q upon A epsilon naught minus Q upon A epsilon naught, since E2 will be greater than E1. Okay, so Q upon A epsilon naught will be common, K minus 1. So this will be the net electric field which will be there in between this. So this is the important concept which we have to see, that when the dielectric will be introduced in this, the opposite electric field will be introduced, since the negative sheet of charge will be here in the first plate which is contact with the positive surface of the capacitor, and the which is in the contact with the negative terminal will be having a positive sheet of charge there. Okay, so the net electric field will be in the opposite direction and the net electric field here will be in the opposite direction. Okay, so the both directions will be opposite, E1 and E2 directions will be opposite, but since the K epsilon naught will be more, so the net will be E2 minus E1. This electric field is inside the dielectric. Okay, so E2 minus E1 will be inside, so Q upon epsilon naught K minus 1, since the electric field will change by or increase by a factor of K. Okay, so this is the important concept, that when this positive charge, when this dielectric will be introduced, a negative sheet of charge will be there here and the positive will be here. So we know that since the electric field is from positive terminal to negative terminal, what is the electric field here? From the positive here to the negative here. So the electric field direction will become opposite to the direction from with the capacitor which is there. Okay, so the capacitor was there with the positive and negative, so the electric field direction was like this. in the positive x, but here the direction is negative x, so net will be E2 minus E1 q upon A epsilon naught minus kq upon epsilon naught. So the net field will be E2 minus E1. So this is the concept how we will find the net electric field when the dielectric constant of K is introduced in a capacitor. Okay, and it will change the electric field by the factor of K minus 1. K minus 1 factor, it will change the electric field. Okay, thank you.